Coulomb's law. According to Coulomb's law, the force of attraction or repulsion between two stationary point charges is directly proportional to the product of the magnitude of two charges and inversely proportional to square of the distance between them. And the direction of this force is given along the line joining of the two charges. To find electrostatic force between two charges, we can use this formula F equal to 1 by 4 pi epsilon naught Q1 Q2 by R square. While doing the problems in SI system, the value of 1 by 4 pi epsilon naught is 9 into 10 power 9 Newton meter square by Coulomb square. Q1 and Q2 are taken in Coulomb, R is taken in meter. One more important thing, force is a vector quantity. It is having magnitude as well as the direction. In vector form, the same expression can be written as F equal to 1 by 4 pi epsilon naught Q1 Q2 by R square into a unit vector in the direction of R, that is R cap. Say here, when two same kind of charges are taken, they repel each other. The forces are acting along this direction. They are along the line joining of these two charges. On this charge, the force due to first charge is acting on the second charge. It is F21. The force due to second charge on first charge is F12. This is along this direction and this is along this direction. And these two are equal and opposite. That is, they follow Newton's third law. Similarly, when a positive and negative charges are taken, they attract each other. These are the forces acting on positive charge and negative charge. Similarly, we consider three charges Q1, Q2, Q3. If these three charges are placed at the corners of an equilateral triangle, they are positive charges. I want to find the resultant force on this charge. On this third charge, the force due to first charge is acting along this direction. Force due to second charge is acting along this direction. Now the net force is the resultant of these two forces. This is the net force. If F1 is this force and F2 is this force, and this angle is theta, the angle between forces F1 and F2, the resultant force is given by parallelogram law of vector addition, that is F equal to root of F1 square plus F2 square plus 2 F1 F2 cos theta. Similarly, in the same problem, if this Q2 is replaced by minus Q2, then we see what are the different forces acting on Q3. This is positive charge, this is positive charge. A repulsive force is acting due to this charge, this is along this direction, and due to this charge, an attractive force is acting, this is along this direction, and the resultant is the resultant of these two forces, and this is along this direction. If this is an equilateral triangle, you know that each angle is 60 degrees, then this is 120 degrees. In this case, F1 and F2 are same. The resultant force is F12 equal to root of F1 square plus F2 square plus 2 F1 F2 cos theta. Taking F1 equal to F2, theta equal to 120 degrees, we get the resultant force is equal to F1 or F2. Now in this case, if this is an equilateral triangle, this angle is 60 degrees. Taking F1 equal to F2 and theta equal to 60 degrees, we get the resultant force Fr equal to root 3 F1 or root 3 F2. Now I am taking four charges Q1, Q2, Q3 and Q4. Now what is the net force on Q4? According to superposition principle, the net force on a charge is nothing but the vector sum of all forces acting on that charge. On this charge, due to Q1, a force is acting along this direction. Due to Q3, a force is acting along this direction. It is F3. And due to Q2, a force is acting along this direction. That is F2. The resultant of F1 and F3 is also in the same direction of F2. Therefore, the net force acting on this charge Q4 is F2 plus F13. Now we take another model. Four charges Q1, Q2, Q3 and Q4 are taken at the corners of a square, and fifth charge is placed at the center. On this charge, the different forces acting are: due to Q1, F1 is along this direction; due to Q2, F2 is along this direction; due to Q3, F3 is along this direction; due to Q4, F4 is along this direction. These two are equal and opposite, these two are equal and opposite. Therefore, the net force is 0. Similarly, if three positive charges are taken at the corners of an equilateral triangle, and positive charge is placed at the center of this triangle, the forces acting on the charge: due to Q1 it is along this direction, due to Q2 this is along this direction, and due to Q3 this is along this direction. Since F1 equal to F2 equal to F3, and this is 120 and this is 120 and this is 120, using triangle law of forces, we can say the resultant force is 0. That is, here the resultant of these two forces is along this direction. Since this angle is 120 degrees, F1 equal to F2, this force is equal to one of the force, and these two are equal and opposite. They get cancelled. The resultant force is 0.